Let's step inside the addicted brain and take a look at how addicted brains differ from non-addicted brains. Scientists have long asked the question, is addiction learned behavior or is it an inherited disease? They've been asking that question for at least 80 years, and we're going to take a look in a few minutes at some of their research, get a few ideas of the answers that they've discovered. But first I want to say that actually this notion of alcoholism and other addictions as a disease goes much further back than the last 80 years. In fact, I brought with me a little excerpt from an article from Scientific American. This was published in 1877, and I think you'll find it very interesting. They write, "Science draws a broad distinction between drunkenness as a vice and drunkenness as a disease. The man who drinks for pleasure, it holds, may look for benefits in the counsel of others or in his own strength of will. But he who drinks because he cannot help it, being led by an irresistible impulse, is a sick man and need not a temperance pledge, but a physician." I find this very interesting because this was written 130 years ago. So when we think, oh, maybe this idea of alcoholism being a disease is a modern notion, it isn't. As a matter of fact, you can find similar writings as far back as the Roman Empire. So next, let's take a look at the twin studies that have been going on since the 1930s, trying to determine, is this genetic or is it learned? Twin studies separate genetics from environment by focusing on the differences between identical twins and fraternal twins. Identical twins have identical genes, and fraternal twins only have some of the same genes. If alcoholism is genetic, then identical twins should be equally predisposed to alcoholism because they have the same genes. Fraternal twins should exhibit more differences in their predisposition to alcoholism because each twin has different genetic makeup. If the influence is environmental, however, the probability that a pair of twins will match each other's predisposition to alcoholism will not change, based on whether they are identical or fraternal twins. The match will be determined solely by their environments, not by the similarity of their genetic makeup. After studying twins for decades, scientists find that identical twin pairs are much more likely to match each other's predisposition to alcoholism than fraternal twins. In other words, alcoholism and other addictions are not learned behaviors, but inherited genetic diseases. In addition to the twin studies, scientists have used animal studies to determine if alcoholism is a genetic disease. And they have been able to genetically engineer rats to either prefer alcohol or avoid alcohol. In other words, alcohol-preferring rats will choose alcohol over water or anything else, whereas the alcohol-avoiding rats, they will not drink alcohol even if they are not given water and they become thirsty. The interesting thing is, when they're bred, alcohol-preferring rats have offspring that also prefer alcohol, and the alcohol-avoiding rats have offspring that avoid alcohol. So again, it shows us that this is genetic, that the offsprings of alcoholics are more likely to be alcoholic themselves. In addition, there have been different studies, such as at Harvard, that have looked at other drugs, such as marijuana, cocaine, heroin, other opiates, to determine, is there also a genetic predisposition to becoming addicted to these drugs? They also use the twin studies, and the answer is yes, that addiction to other drugs is also very much determined genetically. Finally, though, we need to make a very important point. There is an environmental factor here. You have to add the drug. You have to either use alcohol, use marijuana, use cocaine before you become addicted. So you could be wired genetically as an alcoholic, but if you never drank or you only drank very, very small amounts of alcohol and only rarely, you would probably never trigger that genetic code and you wouldn't even know that you were wired genetically for alcoholism. So there is a genetic component, but we are a drinking society. We definitely also, among some circles, are a society of drug takers. So about 1 out of 8 adults who drinks alcohol becomes alcoholic. It's actually not a rare problem. Let's talk about how addicted brains function differently than non-addicted brains. Today, we have great scientific advancements, and we can take pictures and we can take movies inside the heads of living, breathing human beings. And by doing so, we can see how normal brains function and compare them to the way alcoholic brains function. And we've discovered some startling differences between the two. First of all, addicted brains lose the ability to switch strategies when things aren't working. Non-addicted brains, if we try something a couple times, it's not working, we think to ourselves, maybe I better try something different. That doesn't happen in the addicted brain. As a result, addicts don't change their behavior in an attempt to get different results. In Alcoholics Anonymous, they call that insanity. They say insanity is doing the same thing over and over again and expecting different results. In addition, the decision-making in the addicted brain is impaired. Addicts make decisions in much the same way as people with brain injuries. They make decisions based on immediate gratification rather than long-term consequences. This can be very confusing to families because they think to themselves, well, when is she going to learn? All these bad things are happening. Doesn't she see it? Why doesn't she change? The truth of the matter is her brain is no longer able to really register the idea that, boy, if I do this down the road, I'm going to be in trouble. The only thing that matters is what happens in the moment and my need to get high. Additionally, the addicted brain has difficulty determining when things are going wrong. For most of us, when things are going wrong in our life, there's a red flag that goes up, and it says to us, this is a bad situation, or this is a dangerous situation. We need to change things, or we need to get out of here. The addicted brain loses its ability to raise the red flag, which warns us when we're in trouble. It is no longer working in the addicted brain, therefore, again, it confuses families. Can't this person that we love so much see the kind of trouble that they're in? The truth of the matter is, as the addiction progresses, they're less and less able to determine when they're in a bad situation. Finally, the brain's survival instinct is actually hijacked by the addiction. And what do I mean by this? Our survival instinct is there to keep us alive. The brain's number one purpose is to make sure that we survive. When the survival instinct is hijacked by the addiction, it is now working for the survival of the addiction, not the survival of the person. That is why so many people will drink or drug themselves to death. The addicted brain also looks different. The anatomy is different. The effect of the alcohol, the effect of the drugs has caused the brain to shrink and atrophy. One study showed addicted women had a brain that was 11% smaller than non-alcoholic women. What can we learn from all this? It's important for us to understand when we are intervening that the person that we're concerned about is not being a bad person, they are a sick person. As Dr. Daniel Amen, who has studied the brains of alcoholics, has said, not all brains have the same power to choose. Therefore, it's very important for the family members and other people that love the alcoholic to step up and help them get the help they so desperately need.